A mysterious object is currently passing by our sun, and its true nature remains a puzzle. We can no longer observe it directly, but for months, scientists have tracked its movements closely. This visitor is known as ThreeI Atlas, and it's classified as an interstellar comet. In just 4 months, nearly 100 scientific studies have been published about it, with even more unofficial information circulating, some of which sounds quite extraordinary. Today, we will sift through the speculation and uncover the essential facts about ThreeI Atlas. Let's begin with its path through our solar system. Right now, ThreeI Atlas is making its closest approach to the Sun, a phase called Perihelion. The peak occurs on October 29th, when it will pass within approximately 210 million kilometers of our star. In space, distances are often measured in astronomical units, or AU, where 1 AU equals the average distance from Earth to the Sun. This helps us grasp the immense scale of space. 4 AU from the Sun, placing it just inside the orbit of Mars. This is when the object will be most active, reaching its highest temperatures and causing surface material to be ejected into space. This process, known as sublimation, is typical for comets. In the vacuum of space, solids turn directly into gas, creating a fuzzy halo known as the coma, along with a tail. The coma consists of gas and dust released from the object's surface, while the tail forms as solar wind. A stream of radiation from the sun pushes this material away. It's a beautiful cosmic display. Unfortunately, we cannot witness this event for ThreeI Atlas because the sun is blocking our view. It's a matter of positioning. We are simply on the wrong side to see it during this peak phase. So, we know where ThreeI Atlas is and what it's likely doing. While we wait for it to reappear, let's explore how it arrived here. Tracking began in July 2025, when the Asteroid Terrestrial Impact Last Alert System, or ATLAS, detected it. ATLAS consists of telescopes worldwide, in locations like Hawaii, Chile, and South Africa, scanning the sky for moving objects. On July 1st, they spotted it and initially classified it as a new asteroid. But then something unusual stood out: its incredible speed. Everything in the solar system orbits the sun, held by gravity. The closer an object is to the sun, the faster it must move to avoid falling in. If something moves fast enough, it can escape the sun's gravitational pull entirely and journey into interstellar space. When astronomers measured this object's velocity, they were astonished. It was the fastest moving object ever recorded in our solar system. To put this in perspective, Earth orbits at 30 kilometers per second. 4 AU travels at about 48 kilometers per second to stay in orbit, 5 AU from the sun. At that speed, it was clear this visitor would swing past the sun and continue outward. This hyperbolic trajectory indicates it originated in interstellar space and will return there after its tour of our system. This led to the name ThreeI Atlas, indicating it's the third known interstellar object. The first was Oumuamua, which had its own peculiarities, and the second was Borisov, which was surprisingly ordinary aside from its interstellar origin. ThreeI Atlas differs from its predecessors in 3 key ways. First, its size. It's significantly larger, 6 kilometers. Second, its speed. It travels about twice as fast as the others. Third, its direction of approach, which is particularly unusual. Oumuamua came from above, aligned with the solar system's motion around the galaxy. Borisov approached from a similar general direction. ThreeI Atlas, however, came in from the side, almost perfectly aligned with the planets. Our solar system is mostly flat, like a disk. known as the plane of the ecliptic. Few objects deviate significantly from this plane. Pluto, for example, is tilted by 17 degrees. ThreeI Atlas, by contrast, is only 3 degrees off, hitting the solar system in near-perfect alignment. Given the three-dimensional nature of space, this Sidon approach is a remarkable coincidence. So, where did ThreeI Atlas come from? It approached from the direction of the galactic core. From a top-down view of the Milky Way, we're located in an outer spiral arm. The core is bright and densely packed with stars. To pinpoint its origin, consider a side view of the galaxy. Most matter in the Milky Way lies in a thin disk around the core, but there's also a less crowded region above and below called the thick disk. 6 billion years, nearly twice Earth's age. While we may never trace it back to its exact starting point, researchers have backtracked its path over 10 million years, identifying 93 stars it passed near. 3 light-years away, or 63,000 AU, 4 AU from our Sun. Now let's examine its approach and what we've learned. Although officially discovered on July 1st, it was first spotted on May 7, 2025, in images from the Transiting Exoplanet Survey Satellite, or TESS. This Earth-orbiting observatory searches for planets in distant star systems, and coincidentally observed ThreeI Atlas for about a month as it moved through Jupiter's orbit. Astronomers first measured its brightness over time, which reveals composition. 5 times between May and June as it moved closer to the Sun. However, TESS data showed the flux increased 5-fold, indicating a significant rise in reflected light. This confirmed it wasn't an asteroid but a comet forming a coma of gas and dust. 2 oddities emerged from this observation. First, light polarization. When sunlight hits the coma, it scatters. If it scatters sideways, it's positive polarization. If straight back, it's negative. Most space objects, including interstellar ones like Borisov, show positive polarization. ThreeI Atlas, however, displays extreme negative polarization, unlike anything seen before. This suggests that what's normal in one solar system might be unusual in another. The second surprise was the coma's early formation. During May and June, ThreeI Atlas was beyond Jupiter's orbit, over 5 AU from the Sun, a very cold region where comets usually remain frozen. Sublimation typically begins between 3 and 4 AU. But observations revealed the coma was rich in carbon dioxide gas, with some water vapor, at a ratio of about 8:1. This is the inverse of typical comets, which are mostly water ice. Carbon dioxide ice, like dry ice used for special effects, sublimes at much lower temperatures than water ice. That's why ThreeI Atlas developed a coma so far from the Sun. As it approached, the ratio shifted. 5 AU, it released massive amounts of water vapor, comparable to a fire hose at full blast. This sudden release was unexpected, even for a normal comet at that distance. Metals in the coma also presented puzzles. Earlier observations detected nickel but no iron. Nickel and iron usually form together in stellar cores and are found in planets, moons, and comets. Their separation raised questions. Additionally, detecting any metal sublimating at such a distance was strange, as sublimation requires heat. The abundant C-Otwo release might have carried nickel atoms, but that doesn't explain the lack of iron. Later, by late September, iron appeared, and the nickel-iron ratio normalized. So, ThreeI Atlas is becoming more typical, but in a very unusual manner. Tails are another area where ThreeI Atlas behaved differently. Initially, it formed a sun-facing tail, which is atypical since solar wind usually pushes the tail away from the sun. This might relate to the early coma formation driven by high sea Otwo levels. At that distance, solar wind may have been too weak to form a conventional tail. By September, a short, fan-shaped tail developed, pointing away from the sun, more in line with expectations. Not all comets have long, dramatic tails. It depends on composition and distance. For instance, Comet Hale-Bopp had a massive tail in 1997 when it was much closer to the sun. ThreeI Atlas never gets that close, so its tail is shorter. 19 AU of the planet, the closest approach to any solar system body. The Perseverance rover captured images, though they required long exposures and stacking, resulting in streaky views. The European Space Agency's ExoMars orbiter also took pictures, but details remain blurry. Government shutdown, those may not be available yet. We'll have to wait until early December for ThreeI Atlas to reappear from behind the sun. By then, it will be on its way out, with its closest Earth approach on December 19th at 1 AU, 36 AU of Jupiter. The Juno probe, orbiting Jupiter, might capture final images before the object vanishes. As it moves away, ThreeI Atlas will cool and become less active. Its exposure to the sun may have altered it, offering deeper insights into interstellar objects. Many of its strange traits might not be inherent but accumulated during its long journey. For now, we can only speculate, but more answers, and likely more questions, are on the horizon.